squared plus your k value. The a value, or the number out in front, it's going to be how wide, or it's going to determine how wide, which also means compressed, your graph is, which means that it's really a wide open graph, or how narrow your graph is going to be. Narrow is also known as a stretch. Think of it as you grab the 2 points at the top. If you pull them up, it stretches it skinnier. That's a vertical stretch. Compression is, imagine you're placing something heavy on this graph like a book. It's pushing down on the graph and it makes it wider or compressed. Now, the next value we're going to be going over is the h. Your h value is what's inside of your parentheses. This value is going to move your graph left or right. The last value we're going to be talking about is the k. K is whatever you're adding or subtracting to your graph, which is going to move your graph up or down. Problem number 1. The equation y equals negative x squared plus 1 is best represented by which graph? Remember that the negative out in front of x squared means that it opens upside down, which means your graph should be opening downward because it has a negative. So looking at my graphs, I can cross out B and D because those graphs are facing up. The next thing is looking at the number that's being added to it. It says plus 1. When you're adding or subtracting to your x squared, it's going to move your graph up or down. So because it says plus 1, that means that it's going to move your graph up 1 unit. So that means my answer has to be A. Now, if I wasn't sure, depending on the equation that I have, and I wanted to make sure that I got this correct, I can go to my graph and I can type in my equation, which is negative x squared plus 1. When I graph it, I can compare it to the 4 graphs that I have down here. Again, it's opening upside down, so cross out B and D. And then looking at the graph, you can see that it did shift up 1 unit, so I know that it does have to be A. Problem number 2. How is the graph y equals negative 2/3 x squared different from the graph y equals 3/2 x squared? So looking at the first one, negative 2/3 x squared, knowing that it has a negative means that my graph is automatically opening upside down. The other graph has a positive 3/2 x squared, which means that that graph should be opening upward. So here, if I go look at it, it says that on A, the graph of negative 2/3 opens up. Negative 2/3 will not open up. So look at B. Negative 2/3 opens downward. Yes. C says negative 2/3 x squared opens upward. We said it won't open up. And then D says y equals negative 2/3 x squared opens down. So yes, it opens down. Yes, it opens down. Now let's talk about the wider and the narrower part. Remember that if you have a number line, imagine a number line, and in the center is your x squared, or like a 1x squared. As that number gets bigger, so as it goes this direction, as it goes from 1 to like 2 or 3 or 4, your graph is getting skinnier and skinnier and skinnier. As it gets closer to 4, your graph is getting really, really narrow. Okay, as it goes closer to 0, your graph is getting wider. Remember that 0 is like a horizontal line like this. So if I have something like half x squared, it's actually really wide. But as I get closer to 0, it becomes wider and wider. So as I go this way, it's wider. So looking at my sign, we're going to use that same looking at the number, we're going to use that same process to help us here. So 2/3, ignoring the negative, look at 2/3. 2/3 would fall somewhere between 0 and 1, so it would fall somewhere here. So it's a pretty wide graph. Looking at 3/2, 3/2 is like 1.5 or 1.5, which means it falls over here and would be pretty narrow, or getting narrower as I go this way. So if I'm comparing these two graphs, 2/3 falls over here, negative 3/2 is going to fall to the right. So 2/3 is actually going to be wider than the -3/2. So looking at my answer choices, -2/3, it opens downward and it should be wider than the graph 3/2 x squared. So the answer is B. Now, again, if I couldn't tell which graph would be wider, I would definitely go open up a graph and type in my equation. I would type it in without the negative sign because I know that the negative already opens it upside down. What I'm trying to check is what happens to the 2/3 x squared versus the 3/2 x squared. So I know the sign's going to flip it upside down, but if they were both positive, you can see from the graph that when I typed it in, the 2/3, which is the first graph, is actually wider than the 3/2 graph, which is inside of it. So knowing that I can type it in to double check it always helps. Problem number 3. For problem number 3, it says, how does the graph y equals x squared plus c compare to the graph y equals x squared plus 3c if the c value is equal to -2? So they're telling you to plug in a -2 for the c. So let's start with the first graph. So graph 1. The equation is y equals x squared plus c. But here they're telling me that instead of c, we're going to use the number -2. So this is my first equation, x squared minus 2. The next equation tells us to use y equals x squared plus 3c. So this time, again, we're going to plug in our c, but it's going to be 3 times your c, which is -2. So this equation is going to be y equals x squared minus 6. So here I have my two equations and they are both quadratics. So if I were to graph both of these on a coordinate plane, I would start with the first one, which is x squared minus 2. Remember, the -2 moves the graph down 2 units, so it now starts at -2. It's still opening upward because it's a positive x squared. The next graph is x squared minus 6, which means that the y-intercept on the next one is actually -6. So -3, -4, -5, it's actually down here at -6. This graph is still opening upward. So notice the first graph that's in blue, and notice the second graph I drew, which is in green. Here they're asking what happened. So A says the graph of x squared plus c, so the first graph is narrower than the second one. I didn't change anything to the number in front of x squared. It's 1 in front of both of them, so that's not true. B says the graph is wider. It didn't become wider than the other graph. It's just moved down. So here it says y equals x squared plus c. The first graph, the blue one, is below the second one. That's not true either. The graph of y equals x squared plus c, so the blue graph, is above the green graph. That is true. This first one that I drew is above the second one, which is down here. Problem number 4. If the graph of a function of the form y equals ax squared plus c has a vertex that is located below the origin, remember below the origin, it's not going through the 0, it's down here somewhere. So the vertex, which is the lowest or the highest point, is here, and it opens upward, so it looks something like this. Which of the following is true about the values of a and c? Remember that your vertex form is written like this. This is vertex form. Standard form is ax squared plus bx plus c. So here they give you the equation ax squared plus c, which means there is no bx. So they have it in standard form. What they're asking you is what happened to the value of a. So if the graph is opening upward, that means that the a value has to be positive, which means the a has to be above the 0 because it's below the 0. Oh no, that's right. It is positive because it's opening upward. I'm sorry, I was looking at the vertex at where it was. But yes, the graph is opening upward, so my a value should be positive. So we're going to cross out A and we're going to cross out C. So B is good and D is good. The next one is what I was looking at a little while ago, which is your C value. Does it hit above the 0? Is it positive, or is it hitting below the 0 where it's a negative? So here it hits below the 0. So the C value is a negative, which means it's less than 0, which makes my answer D. Okay, problem number 5. Which of the following lists the graphs of the function form y equals ax squared in order from widest to narrowest? So widest, that means that it's closer to 0. As it gets bigger, something like 1, 2, 3, this becomes more narrow. So again, this is wider over here, narrower over here. So we're looking at those numbers and we just have to figure out the order. So 1/4 is 0.25. 4/5 is like 0.8. 3 is just the number 3. And then 7/2, that's 3.5. So here, the widest is closer to 0. So the one closest to 0 would be 0.25. So the first number should be 0.25 or 1/4, which makes all of these automatically wrong. It should start with 1/4, then 0.8, 3, and 3.5. So the answer is A. Problem number 6. The grid shows parabolas R and S in this form. It says how are these parabolas related? So is parabola R wider than S? If you look from R, here this is 4 units apart, and here this is also 4 units apart. So it's not actually wider, it's actually the same width. It's not narrower either. The next one says that R is 6 units below. If you look at R, it is not 6 units below the S. It's actually above the S. So no. And D says all points of parabola R are 6 above the S, which is true, which makes it